How we talk in the silent space. Space, the final frontier. It's vast, it's mysterious, and it's eerily quiet. You see, sound, the very essence of our communication on Earth, needs something to travel through. A medium like air. But space? Well, space is mostly a vacuum, my friends. No air to vibrate, no sound to hear. But don't think for a second that this silence means we can't communicate across the cosmos. Oh no, we humans are far too clever for that. We've devised ingenious ways to send messages through the soundless void, using everything from radio waves to lasers. So buckle up, space cadets, as we embark on a journey to explore the fascinating world of communication in space. Here on Earth, we take sound for granted. We talk, we listen, we jam out to our favorite tunes, all thanks to the air around us. Sound waves, you see, are vibrations that travel through a medium, and air, with its countless molecules, is an excellent conductor. But space is a different beast altogether. It's practically empty. A vacuum with only a smattering of atoms here and there. Imagine trying to have a conversation in a room completely empty of air. You could shout at the top of your lungs, wave your arms frantically, but your words would be lost in the void. That's space for you. No air, no medium, no sound. It's the ultimate silent movie up there. Even if you could scream as loud as a supernova, your cries would be met with deafening silence. Now you might be thinking, if space is a silent movie, how do astronauts chat with each other and mission control back on Earth? It's a fascinating question because, unlike on Earth, where sound travels through the air, space is a vacuum. This means there are no air molecules to carry sound waves. So how do they manage to stay in touch? Well, that's where things get really interesting. The solution lies in the realm of electromagnetic waves, which can travel through the vacuum of space without any problem. Since sound waves are out of the question, we turn to our old friend, electromagnetism. Electromagnetic waves, unlike sound waves, don't need a medium to travel through. They can move freely through the emptiness of space. You see, electromagnetic waves, unlike sound, are perfectly happy traveling through the vacuum of space. This makes them ideal for communication between astronauts and with Earth. One type of electromagnetic wave we use extensively is radio waves. These waves are incredibly versatile and can carry voice, data, and even video signals across vast distances. Think of them as cosmic walkie-talkies. Just like walkie-talkies on Earth, radio waves allow astronauts to communicate with each other and with mission control. Astronauts have radio transmitters and receivers built right into their helmets. These devices convert their voices into radio waves, which can then be transmitted across space. When one astronaut speaks, their voice is converted into radio waves, beamed across space, and picked up by the receiver of another astronaut or by antennas here on Earth. This system ensures clear and reliable communication. And it's not just astronauts talking to each other. This technology also allows them to stay in constant contact with mission control, ensuring that they can receive instructions and updates in real time. We use radio waves to communicate with distant spacecraft exploring the solar system. These signals can travel millions of miles, allowing us to control and receive data from probes and rovers on other planets. But radio waves aren't the only game in town. As our need for faster and more efficient communication grows, we're exploring new technologies. We're always looking for faster, more efficient ways to communicate in space, and that's where lasers come in. Laser communication offers a significant advantage in terms of speed and data capacity. Lasers are like the fiber optic cables of space communication, capable of transmitting vast amounts of data at lightning speeds. This technology is still in its early stages but holds great promise for the future. We're talking high-definition videos, detailed images, and scientific data, all beamed across millions of miles. As we continue to explore the cosmos, these advanced communication methods will be crucial in sharing our discoveries with the world. Now let's zoom out from astronauts and talk about how spacecraft, those robotic explorers venturing into the great unknown, stay in touch with us Earthlings. These spacecraft are our eyes and ears in the cosmos, sending back invaluable information about the universe. Unlike your smartphone, spacecraft don't have the luxury of tapping into Wi-Fi networks or cell towers. They can't just connect to the internet or make a quick call home. They rely on radio waves and a network of giant antennas here on Earth called the Deep Space Network, or DSN. This network is a crucial lifeline, ensuring that we can communicate with our distant robotic explorers. Imagine a spacecraft like Voyager 1, billions of miles away, exploring the interstellar ocean. It's out there, far beyond the planets, in the vast emptiness of space. It has a story to tell, data to share, but how does it do it across such vast distances? The challenges are immense, but the technology is fascinating. Well, Voyager 1, like all spacecraft, has a transmitter and a big dish antenna. This antenna is its primary tool for sending information back to Earth. It gathers all its scientific data from images to temperature readings and even measurements of cosmic rays and magnetic fields, and converts them into digital bits just like a computer. These bits are the building blocks of the information it sends. These digital bits are then encoded onto radio waves and beamed out into space, aimed carefully at Earth. The precision required for this is astounding, given the vast distances involved. This signal, traveling at the speed of light, races across the solar system, covering millions of miles in mere minutes, getting weaker and weaker with every mile. The further it travels, the fainter it becomes, making it a challenge to detect. Here on Earth, the giant dish antennas of the DSN stand ready to catch these faint whispers from the cosmos. These antennas are strategically placed around the globe to ensure constant communication. These antennas are incredibly sensitive, able to pick up signals billions of times weaker than a cell phone signal. They are marvels of engineering, designed to detect the faintest of signals. Once received, the signal is amplified, cleaned up, and decoded back into the original data, allowing scientists to analyze and interpret the information, giving us a glimpse into the far reaches of space. Through this intricate dance of technology, we stay connected with our spacecraft, unlocking the mysteries of the universe. So we've established that the kind of sound our ears are designed to hear can't travel through the vacuum of space. Sound, as we know it, requires a medium like air or water to travel through, and space is a near-perfect vacuum, devoid of such mediums. But does that mean space is completely devoid of any sonic experience? Not quite. While traditional sound waves can't propagate in the vacuum of space, there are other fascinating phenomena that can be translated into sound. While we can't hear it directly, space is teeming with other kinds of waves and vibrations that can be translated into sound. These include electromagnetic waves, radio waves, and even vibrations within gas clouds and plasma. Think of it like translating one language to another. Take pulsars, for example. These fascinating celestial objects are neutron stars that emit beams of radio waves as they spin. These rapidly spinning neutron stars emit beams of radio waves that sweep across space like cosmic lighthouses. As these beams pass by Earth, we can detect them using radio telescopes. Now, radio waves aren't sound, but if we convert those radio signals into sound waves, we get these incredible rhythmic pulses, almost like a cosmic heartbeat. This process allows us to hear the universe in a way that our ears alone could never achieve. And then there are the giant clouds of gas and plasma that permeate space. These clouds are not silent, they vibrate and oscillate due to various cosmic events and interactions. These clouds vibrate and oscillate, and while we can't hear them directly, we can use instruments to detect these vibrations and translate them into sound waves, revealing a symphony of cosmic whispers and roars. This translation process opens up a whole new dimension of understanding the universe. Perhaps the most mind-blowing example is gravitational waves. These are ripples in the fabric of space-time itself, created by some of the most violent events in the universe, like black holes colliding or neutron stars merging. These ripples in the fabric of space-time itself are created by some of the most violent events in the universe, like black holes colliding. When these colossal events occur, they send out gravitational waves that travel across the cosmos. We can't hear gravitational waves directly, but thanks to incredible instruments like LIGO, we can detect their subtle effects and translate them into sound, giving us an auditory glimpse into the cataclysmic events unfolding across the cosmos. This ability to convert different types of cosmic waves into sound allows us to experience the universe in a profoundly unique way. As we've explored, the vast cosmic ocean may be silent to our ears, but it's abuzz with communication. From the radio waves carrying astronauts' voices to the laser beams transmitting high-definition images, we've found ingenious ways to overcome the sound barrier of space. And the future of space communication is even more exciting. Imagine instant communication across galaxies using the principles of quantum entanglement, or spacecraft navigating the cosmos using pulsars as cosmic GPS satellites. But for now, let's take a moment to appreciate the incredible ingenuity that allows us to reach out across the void, to listen to the whispers of distant stars, and to explore the universe, even in silence. So, the next time you gaze up at the night sky, remember that even in the soundless depths of space the conversation continues. We are not alone, and the universe is full of stories waiting to be heard, if we only know how to listen. So, we've journeyed from the sound-filled world we know to the silent depths of space, and what a trip it's been. We've seen how the absence of air throws a wrench into our earthly methods of communication, but we've also witnessed the incredible ingenuity of humankind. We've harnessed the power of electromagnetic waves, from radio to lasers, to bridge the interstellar silence and stay connected across unimaginable distances. And let's not forget the hidden symphony of space, the pulsars singing their cosmic songs, the gas clouds whispering their secrets, all waiting for us to tune in and listen. As we venture further into the cosmos, who knows what other marvels of communication we'll uncover? Maybe one day we'll be chatting with alien civilizations, sharing stories and laughter across the galactic expanse. Until then, keep your curiosity burning bright, keep exploring the universe around you, and never stop asking those big, cosmic questions.